Hey, what's up? Welcome to this new video. This one is paper 1 of May-June 2009 of A-Level Math. Now, with that being said, obviously, let's move on to question number 1. So here we have to prove that the left-hand side E is equal to the right-hand side. So let's try step by step. So the first thing we realize here we have a fraction minus another fraction. But here the base, they are different. Now, whenever this happens, we have to what we have to do. We have seen this many times in O-Level Math. We have to multiply them by each other. You will have 1 minus sin x times 1 plus sin x. Then cross multiply them. So first this times this will give you sin x plus sine square x. And then this times this. Here we have minus, obviously we have to be careful. It will be minus sin x and plus sine square x. Okay, so now we have to simplify. Obviously this and this will cancel out, right? And then on top you will have 2 sine square x. And here, as we can see, we have something like a minus b times a plus b. This is going to be a square minus b square. So a square will be 1 minus b square will be sin square x, and that should be 2 sin squared x over the value of cos squared x, and that will be 2 tan squared x. Because we have to know cos over sine, so sine over cos is tan, and simplify this become this. This is shown as required. Let's move on to the next question. So here we have to find a set of values of k for which the line intersects the curve y equal to this at 2 distinct points. Now, whenever we have 2 distinct points, we realize we have to use what? B squared minus 4ac have to be more than 0. Okay? So let's first solve these 2 equations. We have a line, equation number 1, and the curve, equation number 2. Intersects, so we have to solve them simultaneously. So here we have y already. We're placing this y, you will have kx minus 4 is equal to x squared minus 2x. Send everything to one side, you will have x squared minus 2x minus kx plus 4 is equal to 0. Simplify x squared. Now we can take out the value of minus, so our value of x, you will have plus minus 2 minus k times x. So x will be factorized outside, and then we have plus 4 equal to 0. Then again, we can still factorize. Take out minus, you will have minus, and then here you will have 2 plus this x plus 4. Okay, so now we have this equation. We can write down the values of, this is a, this is b, and this is c. So b squared minus 4ac is what? B squared is this, b squared minus 4 times a times c has to be more than 0. Let's simplify. So first, minus 1 squared is 1. Okay, you will have 2 plus k squared. That will be minus 16 more than 0. Now we can send this directly over here and solve, but let me just do this step by step so we're not confused. We have to expand this. What you will have? You will have 4 plus 4k plus k squared minus 16 more than 0. So you have k squared plus 4k. 4 minus 16 will be minus 12 more than 0. Now obviously we have to first find the critical values of k. That will be factorization. K times k, 12 is 6 times 2. To get plus 4, we need to have plus 6 minus 2. K have to be minus 6, and k have to be the value of 2. Now we just have to use the graph to find the value. So that will be, the first value here is minus 6, and the value here will be 2. Now because the coefficient here is 1, it is positive, the shape will be something like this, right? We have to know this. Now here we have 0, this will be 0. Now we need it to be more than 0 above this line. We need this to be above this line. So it will be on this side and on this side. So it means that k have to be minus 6, or k have to be more than 2. So this will be the set of values of k for which this is true. Let's move on to the next question. So here we have to find the first three terms in this expansion in ascending powers of x. So pretty easy. The first term will be, here we have power 5, we're at 5. Choose 0, that's the first term. And here we have 2, we're at 2. And here we have plus 3x, we're at 3x. Because here we have 0, this will be 0 as well. 5 minus 0 is 5, that will be 5 here. Then the next term will be 5. Choose, after 0 we have 1. And then same thing here, 2 and 3x. Because here we have 1, this will be 1 over here. 5 minus 1 is 4. And finally the third term, so after 1 we have 2. That will be 2 and 3x. This is 2, and that should be 3. Now we just have to simplify term by term and find the value, the exact value of each term. So here obviously it is 1. So let's try 5 combination 0 should be 1. 2 power 5 should be 32, but let's check. Yeah, and in anything power 0 should be just 1. That should be 5 here, and that should be 16, that should be 3x, 10, that should be 8, and 9x squared. But of course always check using your calculator. Now we can simplify, that should be 32 plus 5 times 16 times 3, that should be 240 x, and finally here we have 10 times 8 times 9, that should be 720 x squared. So these are the first three terms of this expansion. Now part 2, hence it means we have to use the value from part 1, find the value of the constant a for which there's no term in x squared in this expansion. It means that when you will expand this whole thing, you will have a term x squared, but it will be 0 here. So nothing, no term in x squared. Find that value for it. So let's first try to expand this and see what happened, right? So here we have 1 plus ax times 2 plus 3x power 5. But now again, this we know already from part 1, right? So let's replace the value in the equation. So here we have 1 plus ax times, this we know already from part 1, 32 plus 240x plus 720 x squared. Now, in this case, we only care about the term in x squared. So let's find that term, x squared. So 1 multiplied by what term or which term will give you something in x squared? So multiply by this, obviously, right? So 1 times 720 x squared. Here we have plus ax times which one? This one. That will give you a term in x squared. So simplify, you will have 720 x squared plus 240 ax squared. Now, we do know that this will give you 0x squared because in the end it tells you here there's no term in x squared, which means this will be the resulting term in x squared. So now we just have to solve, or we have to compare the coefficients. For example, here I can just factorize this outside. You will have 720 plus 240a factorize x squared have to be 0x squared. So now we just have to compare this and this. So as you can see, 720 plus 240a have to be 0, which means a have to be 720 divided by 240. That is minus 3 as your value of a. As we can see step by step how we were able to find that value. Let's move on to the next question. So here we have a graph. As you can see, it should be a sine graph or cos graph, but in this case it shows to be a sine graph. Y equal to a sine bx plus c for the domain between 0 and 2 pi. Now it is same thing as 0 and 360. If you like to work with degrees, this is simply 360. Now we have to use the graph to find the values of a, b, and c. So pretty easy. A is the amplitude of the graph. You have to know this. The value in front of the function is called the amplitude. So how do you find this? By observation. It is simply the distance the equal distance between the height. So the whole thing here will be what? The total height. So 9 minus 3 is 12, divided by 2 should be 6. So this will be the amplitude here and here. As you can see, it should be what? 9 minus 3 is 6. Right? So value of A is 6. Now let's move on to part B. So how would you find B? B is called the, usually we find the value of B by using the period of the thing. But let me find C first. It's the easiest one to find. We just have to look at the intercept, right? This is the point what? This is the point 0, 3. This is the x value and the y value. Let's replace back in the equation. So y equal to 3, when x is equal to 0. Now sine of 0 is 0, so this whole thing here will become 0 plus c. So c will have to be 3. Okay, so right now we have A is 6, C is 3, B, pretty easy. We have to use the period to find the value of B. So by observation, what is the period of this shape? You can see, we begin here. For us to complete one cycle, it took us exactly pi radians, right? So we understand that the period, this is equal to pi, because it took us pi radians to complete one cycle. This is found by using 2 pi, the whole thing, right? 2 pi divided by value of B. Now by comparison, here we have B should be this divided by this should be 2. Okay, so B should be the value of 2. Okay, let me write this down again. So we have to understand the period is simply 2 pi divided by the value of B, right? But now we just find out by using the graph, the period is what? It is to complete one cycle, it took me pi radians, so period is pi. Now solve for the value of B. B is equal to the value of 2. But again, this is the main thing we have to know or remember whenever this kind of question that we have. Period, we have to use period to find this value here in the beginning, in most cases, yeah. Now let's move on to part 2 of the question. So find the smallest value of x in this interval for which y equal to 0. Okay, so right now we have A, which is 6 sine 2x plus c equal to 0. So let's see what is the value we can have for this. So let me check also on the graph itself. For example, when y equal to 0, that will be what? We know that it is on the x-axis. When y is 0, x, it is the x-axis. So on the x-axis, the first value of x should be this one, right? So we have to find that value by solving this equation. So let's try and do this. So first thing first, make sine 2x become subject. You will have minus 3 over 6, right? Send this over here, divide by 6. Sine 2x will be minus half. Now we understand when cos is negative, because we have A, S, T, C, this is everything is positive, sine is positive, tan and cos is positive. Now sine is negative, it will be in this quadrant and in this quadrant. This is the value of 360 minus theta, and it will be 180 plus theta. But now again, the reason why I'm going off for the value of theta, which is not your answer, is because here we have negative value. If it was positive, I can find this directly, but if it is negative, I will go through a fake angle called theta in this case. Now again, this is just a method. If you guys can just learn by this method, it will be way easier for you guys to do any kind of question. So whenever it is negative, I will have to look at my quadrants and work with a fake angle first. So theta is what? It is sine inverse of the positive value of this. Okay, this is not your answer. Theta is not your answer. Sine inverse of 0.5 should be 30 degrees. Okay, so now according to the quadrant, we have to find the value of 2x. 2x is equal to, according to this, it is 180 plus theta. So 180 plus 30, that should be 210. And then we have this one, that will be 360 minus 30, that should be 330. Okay, which means x will have to be what? 210 divided by 2, that should be 105. And then 330 divided by 2, that should be 165. So obviously we'll take the smallest value of x, which is this one, 105 degrees. But I think here we have in terms of radians, so we have to convert degrees to radians. So pretty easy, because we know that 180 degrees is equal to pi radians. So what is 105 degrees? Pretty easy, that will be pi divided by 180 times 105. So pi divided by 180 times 105. That should be 1.8325, but correct to 3 SF, that should be the value of 1.83 radians for the value of x, so the first value of x. Now again, you can always change your calculator to radians and find the value. For example, sin inverse of 0.5 should be this, and then we have, according to the quadrant, will be 180 minus, sorry, not 180, but pi minus answer, that should be this, then divided by 2 should give you the value of, should be plus, my apologies. So sin inverse of 0.5 should give you this, then we have pi plus the value according to the quadrants, then divided by 2 should give you 1.83 as well for the value of x. For the first value, the smallest value of x, right here, this is what we are trying to find for your answer, and that is your question in relation to trigonometry. Let's move on to the next question. The diagram shows a circle center O. The circle is divided into two regions. Okay, as we can see clearly, we have two regions. One is this one, and one is this big one, right? Now, by the radii OI and OB, so here we have radius OA and OB. Okay, what else? The angle here is theta. Okay, good to know. Now, the perimeter of the region 1 is equal to the length of the major arc AB. So here we can form an equation. So the perimeter of R1 is equal to the arc AB, the major arc AB, this one. So here we have an equation that we can use to show the following values or answers. So how would you find the perimeter of region R1? So by observation, perimeter is the region around the object, or the length around the object, so that will be this plus this and plus this, right? So let me write this down. So for now we know this is theta, so this will have to be what? Because we know the whole thing is just 2 pi, that should be 2 pi minus theta, right? That's the angle over here. Now, do we know the radius? No. Let's call the radius R here. R. Right. So the perimeter should be what? Should be radius plus radius, so that is 2R. And plus this one, that should be R times this, should equal to arc length, which is this angle, times the radius. Right? If that makes sense. Because we have to know the formula here. Arc length is equal to radius multiplied by the angle in between, which is the angle in radians. So we have to know this before we do these kind of questions in circular measure. Now we can simplify, we can factorize. This will be this outside 2 plus theta, that will be 2 pi minus theta, that should be R. Now R will cancel out, obviously you will have 2 plus theta is equal to 2 pi minus this. Now we can simplify, send this over here, you will have 2 theta should be 2 minus 2. From here, theta should be this minus 1, and this is shown as required for part 1 of the question. Now, given that the area of R1 is this one, okay, we have to find the area of region R2, correct to 3SF. Okay, so here we have area of this one is given by 30. Now, how do you find area of sector R1? So pretty easy. Again, we use the formula that we know, which is half R squared theta. This is how you find the area of this shape. So let me write this down. That will be half R squared theta is equal to 30. Now we know the value of what? Let's first cross multiply this. That will become r squared. Theta is this minus 1 is 60. R squared is 60 minus 1. Right. So now we know this value. We can use that to find the area of R2. So again, R2 is also a major sector, right? So again, we have to use the same formula, which is half r squared and the angle in between here. That will be half. R squared is given to you by 60 over pi minus 1. And times the angle here will be just 2 pi minus theta. Theta is found to be this. Right. So here we just have to solve for the value of this, correct, to 3SF. So theta is this minus 1. And angle is this minus theta times 60 times 30, because it will cancel out obviously, and divide by minus 1. That should be 58.0165. But let's double check. So here we have 30 divided by minus 1 times pi plus 1. Should be same value. So your area for R2, correct to 3SF, should be 58.0 centimeters square. Okay, that will be this question in relation to circular measure. Okay, so let's move on to the next question. So relative to the point O, that is O from O, the position vectors of A, B, and AB are given to you as follows. Now, I like to rewrite them as vectors, which is 2, minus 8, 4, and OB as 7, 2, and minus 1, right? Same thing. Now, part 1, we have to find the value of this, okay, and hence state whether the angle AOB is acute or obtuse or a right angle. So pretty easy. Let's first find this. So OA is 2, minus 8, 4. OB is 7, 2, minus 1. Okay, so let's solve. So 2 times 7 should be 14, plus this will be minus 16, plus minus 4. So here we have this minus 16, minus 4. It should be minus 6. So the value here is negative. Now we have to know the usual formula is what it is. OA dot product of OB should be magnitude of OA, magnitude of OB, and cos of the angle AOB. Right. Now cos, when it is negative, where does it fall? Here, this is ASTC. It will be in this quadrant or in this quadrant, right? But in this case, obviously, it will be this one, the first one, which is obtuse. Okay. It will be obtuse. It will be in the second quadrant. So obviously by elimination, it cannot be acute. As you can see, it is not acute. Acute means less than 90. It cannot be right angle, because if it was right angle, that should be 0. So obviously by elimination, we have only one left, obtuse. Now, if you guys still want to double check, you can always solve the equation and find the values. For example, I can find that. What is the magnitude of OA? It is 4, so square everything, right? So here, 2 squared is 4, plus 8 squared is 64, plus 4 squared is 16. That will be this. Root of answer is this. So here we have 9.165. And OB, same thing, 49 plus 4 plus 1, root 7.348. So here we have minus 6 divided by 9.165 times 7.348. Now we have to find cos inverse of that. Should be in terms of degrees. Again, I messed up. Let me try again. That would be 9.165 times 7.348. Then we have minus 6 divided by answer. Cos inverse of that should give you more than. The angle is 95.1, which is more than 90. It should be obtuse according to your calculation. So that is part 1 of the question. Now part 2. The point x is such that we have this equation. Okay, so find the unit vector in direction of OX. So first we have to find OX, but we have to use this. AX is equal to 2 over 5 AB. So first we can find AB. AB by definition, we have seen this many times before, is simply OB minus OA. OB is 7, 2 minus 1. OA is 2 minus 8, 4. That should be what? 7 minus 2 should be 5. 2 minus 8 should be 10. And then minus 1 minus 4 is just the value of minus 5. Right. This is AB. Here we have AX. AX is simply OX minus OA is equal to 2 over 5 times AB. That should be 5, 10 minus 5. Simplify. So OX will be, cancel out, that should be 1, 2 minus 1 times 2 should be 2, 4 minus 2 plus OA, that should be 2 minus 8, 4. That should be 4 minus 4 and 2. So this is the value of OX. Now we have to find the unit vector in the direction of OX, so pretty easy. We just take OX and divide by its magnitude to find the unit vector. So magnitude will be 4 square. 4 square plus 4 square plus 2 square. That should be this, 36. So the magnitude will be square root of 36. That should be just 6. So the unit vector should be what? The vector itself, which is this, divided by 6. So we can divide by 2 here, you will have 1 over 3. And that should be 2i minus 2j plus k. Or you can simplify if you want to. 2 over 3i minus 2 over 3j plus 1 over 3k. And that is your question number 2, where you have to find the unit vector of OX. Let's move on to the next question. So here we have to find the sum to infinity of a geometric progression with the first 3 terms, this, this, and this. So sum to infinity is equal to 1 over, what is the equation? Sorry, it is not 1 over, it is a over 1 minus r. Okay, so let's first find the value of a and the value of r. So here we have the first term is equal to 0.5. First term is obviously a. And what is the common ratio? We understand that to find the common ratio, we take what? The first term multiplied by r will give you the second term, which means r have to be 0.5 square. 0.5 square is 0.25. So the value of r is 0.25. Just replace back in the equation. A will be 0.5. 1 minus 0.25 should be what? Should be 2 over 3 as your sum to infinity. That is part 1 of the question. Now for part B, the first 2 terms in an arithmetic progression are 5 and this. So this is the first term, which is a. Second term, which is 9. Now again, we realize that when you have 5, 9, it is an AP, and the common difference will have to be the value of 4, plus 4. So D will be the value of 4. Okay. Now the last term in the progression is the only term which is more than 200. Okay. Find the sum of all the terms in this progression. So pretty easy. Let last term be equal to L. So we know the last term is equal to more than 200. So how do you find the nth term? For example, we know the nth term is given to you by the formula, which is a plus n minus 1 times d. Now nth term, when n equal to L, that should be a is 5. That should be L minus 1 times d should be 4. That is 5 minus 4 is 1 plus 4L. That is my last term. As you can see, my last term has to be what? 1 plus 4L more than 200. So 4L has to be more than 199. L has to be more than 49.75. So the last term has to be at least more than 49. The next integer after this number should be L should be 50. If that makes sense, right? Because term is always integer terms, right? We cannot take a term which is 49.75 term, if that makes sense. The next integer after this will be 50. So in total we have 50 terms. Now we have to find the sum of the first 50 terms. Find the sum of all the terms, so we have to find the sum of the first 50 terms. So pretty easy again. We just use the formula we know already, which is half times the value of n, which is 50, times 2a. 2 times a is 2 times 5, which is 10, plus the value of n minus 1, n is 50c, minus 1 is 49, times d, d is the value of 4. Okay, so let's find out. So half times 50, this is simply 25 over here, and the value inside should be 10, plus 49 times 4, that should be 206. So times 25 should be 5150. Okay, that should be the sum of the first 50 terms of this progression. So the main idea here is we had to find the last term of this progression by using the formula that we know, or the given information, and then from that we have to find the sum of all the terms. Now we know all the terms is 50 terms, sum of the first 50 terms by using the formula to find this. This is given to you again, you don't need to memorize the formula, we just have to replace and find that value at the end. The diagram shows a point ABC lying on the line 2y equal to x plus y. So here the line is 2y is equal to x plus 4, sorry. Now what else? The point A lies on the y-axis right here. Now what do we know at y-axis? On the y-axis the value of x have to be 0. Replace, you will have 2y have to be 4 and y has to be the value of 2. This is the value of 2. So the point A is 0, 2. Okay, now what else? And the length of AB is equal to the length of BC, as we can see right here. Okay, which means B is the midpoint of AC. Okay, good to know. Now what else do we need to know? The line D, the line from D, which is D is this point, 10 minus 3, to B is perpendicular to AC. Okay, now find the coordinates of B and C. Pretty easy. Now the first thing we realize is that B is a point of intersection between the line AC and the line BD. Okay, so because it is the point of intersection, we have to solve a simultaneous equation, if that makes sense. So we already have the equation of AC, which is 2y equal to x plus 4. Y will be half x plus 2. That makes sense. Now by looking at this equation, you can see the gradient of AC has to be half. So the gradient of AC is equal to half. From here we can confirm that the gradient of BD have to be minus 2. Okay, so hopefully that makes sense, because whenever we have two lines at right angle, they have a relationship. If this is half, this will have to be minus 2 as the gradient of the other line. Now we have a passing point, which is 10 minus 3. This is my x value and my y value. I can use that to find the equation of my line BD. So y minus 3 over x minus 10. That should be equal to the gradient. Cross multiply, you will have y plus 3 minus 2x plus 20. Y will be minus 2x plus 17. That is my equation for the line BD. That is my equation number 2. Equation number 1 and number 2. Now we have the equation of this line and this line. We can solve simultaneously because they meet right here to form the point B. This is y as my subject already. Replacing this y, you will have on one side minus 2x plus 17 is equal to half x plus 2. Now I can send this over here, you will have 15. Send this over here, you will have 2.5x. Half plus 2 is 2.5x. X will be 15 divided by 2.5. That should be 6 as your value. Okay. From here, we can find the value of y. Y will be replaced right here. You will have minus 2 times 6 plus 17. That is minus 12 plus 17, that will be my value of 5. So the point B, x value is 6 and the y value should be 5. This is my point B. Okay, pretty easy. Now next thing is we have to find the point C. Obviously here we can use the vector movement. Okay, vector movement, same thing. This is the value of 2. Now from A to go to B will be what? Will be moving, because we know B is the point. Let me mark this down. This is the point 6 and 5. Okay, from A, if you want to go to B, you have to move 6 here, right? 6, and then up by, from 2, that will be up by 3. So 6 in this direction and up by 3. So by a vector movement of, because always the way we describe vectors is first we describe them horizontally, so 6 in the positive direction and going up by 3. So from A to B we have to move 6, 3. The same logic applies because we know that AB and BC are of the same length. From B to C we have to move the same thing, 6, 3. So the point B is 6, 5, moved by the same vector should be 6, 3. That will give you 12, 8. The point C will be simply 12, 8. Okay, and that will be how you can find your coordinates of your point C. Let's move on to the next question. The diagram shows the part of the curve y equal to 6 over 3x minus 2. This is the curve 6 over 3x minus 2. Okay, now part 1, we have to find the gradient of the curve at this point. Again, to find the gradient, we understand the gradient is simply dy by dx, right? Always, gradient of curve is simply dy by dx. Now look at this. We can rewrite this as 6. We can bring this up. Okay, so dy by dx will be what? First, multiply by the power should be minus 6. Then minus 1 to the power should be minus 2. Then multiply by d by dx of the value inside, that should be 3. That should be minus 18 over the value of 3x minus 2 squared. Now we have to find this value when x equal to 2. Replace, you will have 3 times 2 minus 2 square, that should be this, minus 18 divided by value should be minus 1.125 as my gradient at this point. Let's double check. So 3 times 2 is 6, minus 2 is 4, 4 square is 16, minus 18 divided by 16 should be this value or this value for the gradient. That will be part 1 of your question. Okay, now part 2, we have to find the volume obtained when the shaded region is rotated through 360 about the x-axis. So again, about the x-axis, so pretty easy. About x-axis rotation, we just have to know the formula, which is integration pi. When you have x here, you have to write y square respect to dx. And the limits are between 2, 2, and 1. So we know y is given to you by this value, which is 6 over 3x minus 2. What is y squared? That should be 36 3x minus 2 power minus 2. That makes sense, right? That will be y squared. Replace back in the main equation, that should be integration 2, 1 pi. That should be 36 3x minus 2 power minus 2 dx. So now we have to simplify. Let's take this value outside. These two are only multiples. 36 pi, we can take it outside. So right now you only have this to work with. That makes sense, right? Now this is much easier to look at, and then we can simplify step by step. So this will be just outside 36 pi. On the inside, well, first thing we have to increase the power by 1. That will be 3x minus 2 plus 1. That should be minus 1. Then divide by the same power. Then divide by d by dx of the value inside. That should be 3. That should be limits to 1. That will be simplify 1, 12, and that should be 12 here, pi minus 1 over the value of 3x minus 2. Limits to 1. Okay, so now final step, we just have to simplify. 12 pi is 12 pi. So here we have to first replace the value of 2 here. You will have 3 times 2 minus 2, that should be 4. So minus 1 over the value of 4. Here we have minus, and then we have minus 1 over 3 times 1 minus 2, that should be 1. Simplify. 12, that should be minus 1 over 4. Here we have minus become plus 1. That should be simply what? 3 over 4. Now we can simplify, cancel out. That should be 3, and you will have 3 pi times 3. That should be 9 pi units cubed for the volume that we have when we have this rotation about the x-axis. Now let's move on to the next question, question number 10. So the function f is defined by f of x equal to this, okay, where x is between the value of 0 and a. Okay, now we have to express f of x in this form. So pretty easy, step by step. First we have 2x squared minus 12x plus 13. Now we have to check. The coefficient here of x squared is 2. We have to make this become 1. So we factorize 2 outside. That will become x squared minus 6x. And for this one, I can just leave this outside. We don't care about this one. Okay. Now because this is 1 here, we can proceed to the next step. Now we have 2 here. That should be x squared minus 6x plus something. The value here is 6. We plus 6 divided by 2 square. Now when you plus something, you also have to minus the same thing, right? So you don't change your equation. If that makes sense. Now because it was inside the bracket, we also have to give it the value of 2, right? Now simplify. X squared here, we have to write x. Here we have minus, we write minus. Here we have 3, we write 3. And here we have square, we write square. And that will be plus 13 minus the value of 36 over the value of what? So here we have minus 2, that will be 4. Cancel out, you have 2 remaining here, right? If that makes sense. So let's try. 6 divided by 2 square times minus 2 should be minus 18. So here we have 2x minus 3 square. 13 minus 18 should be minus 5. Okay, so here we have this in this form where the value of a is 2, b is minus 3, and c is minus 5 by comparison. That will be part 1 of the question. Now for part 2, state the value of a for which the graph this has a line of symmetry. Okay, so let's see, where can we have a line of symmetry? If you observe, because for this kind of question usually we have to look at the shape of the graph, because here we have 0. Let's replace 0 first in the equation. What is f of 0? You will have replace 0 here or 0 here even. That will give you 13. If you understand, the shape of the graph will be something like this. For example, it is something like this, right? Because here you have for the value of, sorry, this is 0 here. Okay, it is not like this because it is from 0. So we have passed the value of 0. We have to make something kind of accurate for you to understand. So 0 here will be something like this, right? So 0 here, that will be 13. Now this is my first point, and my value of a should be somewhere over here. Now my idea of that is I would need to choose a value of a for which my curve will have a line of symmetry. Now there's 2 ways of doing that. Obviously I understand this point here also have to be 13. However, pretty easy way as well is we can look at this distance. This and this will have to be the same. What is the point over here? Let's find out. The point over here is simply the minimum x value, right? Because that's the minimum point. And by observing this equation, that value is when x minus 3 have to be 0. X will be 3. So the value here will be 3. So this is 3. This also have to be 3. So 3 plus 3, that should be 6. So the value of a will be 6, for which you will have a line of symmetry. Okay, I hope that makes sense, right? Now for part 3, when the value of a has this value, find the range of f. The range of f is the y value of f. So by observation you can see the value of f is between those two, between this point here and the max value here. So the point here is what? Let's find out. This is the point when the value of x is 3. that will be the value at the end, which is -5. So f, or the range, you can write y, between the value of -5, that's the minimum value here, 3 minus 5, and the max value is 13. That is part 3 of the question. Okay, now here we have function g is defined by this. Again, it is the same equation, right? Same thing. 4x is more than 4. Explain why g has an inverse. It is true because it is a 1-to-1 function. This is always going to be the answer, why they have an inverse or why they don't have an inverse. If they have an inverse, it is a 1-to-1 function. If they don't, it means they are not a 1-to-1 function. Okay. Now again, just to explain, because the graph was this shape before for this domain. Now, because we changed the domain now, only after the value of 4, the graph will look something like this. That makes sense. Now, as you can see, if I were to draw a line, I have only one point of intersection, and this means a 1-to-1 function. Compared to here, if I were to draw a line, you have 2 points of intersection, and that will not be a 1-to-1 function. Now, because of that, we conclude in this case it is a 1-to-1 function, and because of that it has an inverse. Now, part 4, obtain an expression in terms of x for g inverse of x. So step 1, let y equal to g of x, which is this one, 2x minus 3 square minus 5. Now we have to make x become the subject. So first thing first, and this over here, you will have this plus 5. That will be 2x minus 3 square. X minus 3 square should be y plus 5 divided by 2. X minus 3 should be plus minus root of y plus 5 over 2. So finally, x will have to be 3 plus the value, or minus y plus 5 over the value of 2. Now in the end, we have to choose, right? In this case, x have to be 3 plus the value of this over 2. Sorry, that will be g inverse of x. Because the domain here is more than 4, it has to be always be positive here. That's why we have to choose this value. Let's move on to the next question. The diagram shows the curve y equal to x cubed minus 6x squared plus 9x, okay, given to you for x more than 0. Okay, the curve has a maximum point at A and a minimum point at B, which is on the x-axis. Now we know on the x-axis the value of y should be 0. Okay, now what else? The normal to the curve at C, right here, the point 2, means the normal to the curve at B, at the point D right here. Okay, now we have to find the points A and B. So let's find those 2 points. Now as we can see, the point A and B are the stationary points, so we know that at stationary points, which is the maximum and the minimum points, we know dy by dx have to be 0. So let's find dy by dx. That will be 3x squared minus 12x plus 9 have to be 0. Now we can simplify. Let's divide by 3 everywhere. You will have x squared minus 4x plus 3, that have to be 0. Now we can factorize, obviously. That will be x here, x, 3 is 3 times 1. We need minus 4, that have to be minus 3 minus 1. X will have to be 3, x have to be 1. Now, for this value of x, let's find the value of y. Replace back in the equation you will have. So 3 squared is 9 minus 6 times, 3 cubed. 3 cubed is 27 minus 6 times 9 plus 9 times 3. That should be 0 because it is this point right here, right? The point B is 3, 0. This is for the point A, 1 minus 6 plus 9 should be the value of 4. So y will be the value of 4 over here. The point A should be 1, 4. Okay, so now we have the point A and B. Great. Now part 2, we have to find the equation of the normal to the curve at C. Okay, so we know the point C is the point 2. To find the equation of a normal, again, normal is a straight line. To find the equation of a straight line, we must find the gradient of the normal. But now we understand, to find the gradient of normal, we first have to find the gradient of tangent, because we have dy by dx. So tangent is simply, or gradient of tangent is simply dy by dx. So dy by dx at the point C, where x equal to 2. Let's see, what do we have? Replace, this is dy by dx, 3 times 2 square minus 12 times 2 plus 9. That should be minus 3. That should be minus 3 as my value of dy by dx. Okay, great. So what else do we need to have? From this, I can conclude that the gradient of normal have to be 1 over 3. Because tangent and normal, they are at 90 degrees to each other, or they are perpendicular to each other. Because of that, we can derive this. Okay? So again, if you guys don't know, let me write this down for you again, because I get this question all the time. Why is this like this? Because they are perpendicular. Always remember, tangents and normal, they are perpendicular to each other. Because of that, I can say the gradient of tangent multiplied by the gradient of normal have to be minus 1. So here we have to use this to find the gradient of normal. We have the gradient, we have the passing point 2, 2, x and y value. We can find the equation of the normal. So y minus 2 over x minus 2 has to be 1 over 3. Cross multiply, you will have 3y minus 6 is equal to x minus 2. 3y will be x minus 2 plus 6 should be plus 4. So this is your equation of the normal at the point C. Again, you can simplify, make y become subject. It is up to you. Now for this one, we have to find the area of the shaded region. Okay, so before we do this, actually, how about we find the point D? Now we know that the point D, the line DC, the line BD is vertically upwards, as we can see here. We know the x value of D will have to be the same as B, which is 3. So what is the y value? Let's find out. Replace the value of x in this equation here to find the value of y. So CD was found to be 3y equal to x plus 4. Now for the point D, we know the value of y, which is 3. Sorry, x, which is 3. We have to find the value of y. Replace, you will have 3y has to be 3 plus 4. So y has to be 7 divided by 3. 2 1/3. Okay, that is my value of y for my point D. Again, let me show you guys why this is helpful. For example, here, I know now the height here is what? The height of this is 2 1/3. And here I can draw this line. What is the width of this? So the point C was found to be 2, 2. This is 2 here, right? 2, 2. And again, this is the height 2 over here. And the point B was 3. Right. Now we know all these values now. We can definitely use that somewhere to find something that we need. Now to find the area of the region, so by observation, step by step, what can we see? So we need this area, right? So to find this area, we must first find the area of the whole thing, right? And then minus the area that we don't need, which is area under curve. If that makes sense. So number 1, area of the whole thing is what? So by observation, let me take it out for you. It is this is vertical, and this is like this. This is the value of 1. This is 2. This is 2 1/3. It is area of a trapezium, obviously. So area of a trapezium is half times sum of the parallel side, that should be 4 1/3, and times the length in between, that should be times 1. So half times 4 this times 1, that should be 2 1/6. This is the area of the whole thing. So now we have to minus area under curve that we don't need, right? And this is done by using integration. Area under curve is done by integration between the limits of, this is 3, this is 2, so 3 to 2. Y is given to you by x cubed minus 6x squared plus 9x respect to dx. That should be x power 4 divided by 4 minus 2x cubed plus 4.5 x squared between 3 and 2. Now simplify. 3 power 4 is 81 divided by 4, that should be, first is 20.25, then we have minus 2 times 3 power 3, 2 times 3 power 3 should be 54, and here we have 4.5 times 9, that should be plus 40.5. So minus, now for 2 power 4 is 16 divided by 4, that should be 4, minus 2 times 2 power 3, that should be 16, plus 4.5 times 4, that should be 18. So simplify here and here, you will have 20.25 minus 54 plus 40.5, that should be 6.75, and minus 4 minus 16 plus 18, that should be 6. You have 0.75. So the area that we do not want here below the curve is 0.75. So finally the area that we want, it is 1/6 minus 0.75. So 1/6 minus, answer should be 1/6 minus 0.75 should be 1/5/12. If you want to, 17/12 units square for the area value. And that will be a question. It's pretty interesting, but as you can see, anything can be done step by step and by observation.